That's a good start. Right. Cursor. Where I left off before, the types of snapping tool that I have work basically in that they are created correctly in the right positions and they sense the correct nearby snapping points. Almost everything else about what I've written has to change. I was kind of aware that this was the way it was going to be. Actually, I'll just run it again because it's the quickest and minimize it. Now, this is the piece of code from here sorry, my mouse wheel is really bad to hear. This piece that draws the guides as they appear just now, not the guides, the snapping tools as they appear just now. And obviously it's not really drawing them. It's drawing the grid, it's not drawing shapes for the other snapping tools, and it's drawing these hotspot things, the things that indicate where those snapping points are being figured to be when they shouldn't be drawn. So all of this is just kind of what it has been for, has been to clarify my thoughts on what needs to be figured out. But actually none of this belongs in here. The reason it's in here is because this is where the gadget gets drawn, that big work top gadget. So I wanted to draw the things I was figuring out. But really it doesn't belong in here. What belongs in here is a loop that draws all currently existent and active snap tools. At the moment this is a loop that does go through a set of existent snap tools, gets the nearest and draws it. But this list of existent snap tools is generated 2 if statements ago, just earlier in this very function. That's not the place to generate that. The list of snap tools should be in existence when the draw method that I'm inside just now is called. And really each existent snap tool should just have a method called draw. So one thing that I need to do is make another method inside my snap class, which is draw, which takes a method like this, a class like this with a couple of variables, and draws it. And I think that what gets passed into that method is a matrix, a transformation. Maybe a matrix and a color. A slight doubt I have about that is, do I want individual types of snap tool to contain multiple colors? When a snap tool is active and visible, like the grid is just now, do I actually want to highlight the intersections, the horizontal and vertical lines that make the intersection that is the current nearest snap? Imagining the way that I want the corner snap tools to look, the ones that will be length and angle based, which you can see responding, they will radiate and be concentric around, radiate from and be concentric around the corners adjacent to the select corners, so from here and here. And again, they could be sort of a similar color to this grid, but they maybe could highlight their nearest snap point. I really want to turn off grid and angle so I can just see the lengths. Yeah, it is confusing. And I think it will be more clear when there are guides. At the moment there should be a series of concentric circles all around this snap point, all around this corner control. Or technically, where should it be? Anyway. Yeah, it's really strange. It's going to be strange editing these things when there's animation present. Anyway. So, that's one thing. Why did I always close that? That's one thing, is the drawing method. The code that draws one of these snapping objects must be within the snapping object. So that in the recursor code here, the loop I actually perform is something more like each current snaps. What I imagine current snaps being, no, it's not really good, that is it. It's like current constraints. I'm just going to call it constraints. I know I said that word could be used for meaning many things, but in this case it's going to be a reference to a linked list, so it's just something that will be stored inside the worktop gadget, among a bunch of other things. But it will be sustained between functions. It's not just for the draw function. All of the stuff that is above this loop just now will be getting rearranged. Just now I'm just kind of trying to imagine what this should look like. And I think, what do I think? I'm going to think about the commands I'm going to use to draw this for a moment. And in GUI classes there's gdraw, and I need an image, x, y, and some things. Right, okay, and this will draw to the canvas. That's what I'm going to have to use. Yeah. This problem, the reason I'm hesitating here is that all of these G functions and classes, they're sort of associated with the GUI, but they have come to be by a roundabout way and are soon to be subject of a big rearrange. These methods draw to the GUI canvas, which is the back buffer in this case. It's just I keep track of it. Roundabout conversation and chat, sorry. So I will use gdraw, because it's going to draw to the right place. And X, Y, width, height, color, blend mode. So if I pass in X, capital X, which is the transformation from world position to screen position, and I pass in a color, and the color is the grid color, whatever it is, guide color, yeah, for now. I suppose that the alternative is that guides kind of store their own color, but I'm not going to do that just yet. Now I'm going to start from the excuse me, an incoming call, who is someone I don't know, which means I don't want to buy anything from them. It's telling me there's an error here, and it's because I haven't defined constraints, and I'm tempted just to respond to that error and go straight off and do that. These will, before I do that though, I will say let me make sure that C is a G call. I'm sure it is. It might just be an integer though it's an unsigned integer. Do I want to send? No, I don't. I want to send an actual color. And that's okay. Sorry, I thought I was sending call. I'm sending guide color, that's fine. I do want to send a color. I don't want to send an unsigned integer because I want to play with that color when I get it. I'm going to use it and then maybe just, well, we'll see. Let me see for a sec. Okay, we'll see. So these will need these things, and I will just get this in here as well. And maybe what I'll do is stick this in. These things have to be coded at some point. It's a way of me avoiding thinking about, oh, this is going to go. I can't be bothered thinking about that just now. It saves me thinking about rearranging that draw method inside the work zone for a while. And apart from anything, I can just go straight to the work zone and nab the bit that draws the grid. This whole thing is going to be totally unnecessary. So I will need that, not the snap last bit. The rest can disappear for now. Let me think. Do I just want to move that wholesale in? Project grid snap size. Okay, right. No, that's fine. Yeah. Yeah, I'm just going to move it in. That's fine. I'm sure I could neaten this up when I look at all those horrible little locals. No, I shouldn't care. I shouldn't worry about. Okay. Right, at this point I'm making use of display Z to decide this. If I'm going to use a matrix, which I am, I have to do it differently, but that's okay. It's a screen grid size Tn float equals OT minus FL. Oh yes, right. Gosh, it's so easy to forget this. But anyway, yeah, that figures out the sort of like the grid square that the left hand side of the screen falls in. Now, if I'm going to use a matrix, then I need to do some more jiggery-pokery, and I might, this is where I'm sure that this is bad practice, but what I like to do is just store things like this. Things which I know I'm going to use all the time. No, that's not good. I will just have V, capital V for vector, and transformed capital V for transformed vector G vector equals new G vector. Yeah, I am going to have that. Because here I'm going to say V equals set X size, comma Y size. Oh, I hate this actually. Now that I think about it, this isn't sensible either. What I'm trying to do is figure out the scale of the grid size on the screen. So what I was about to do there is set a vector to be the grid size, stick it through the matrix, but I actually need to know origin as well. Gosh. To get that x, it's to get the information about the x and y size out of the matrix, which I do need to do. I really am quite frustrated, but I just need to do it. Okay, yeah, there needs to be another couple of vectors here, and they are for O g vector equals new g vector, and that is 0, 0, 0, 0. I'll make that explicit because, and I'm sure that there's a wiser way. Transformed O, okay, can't do that. Why must life be difficult? O transformed, yeah, fine, vector and vector transformed for consistency within this one class on its own equals new g vector. So space inside grid snap for doing its little sums, and I say x transform vector, no m transform vector, it will happen to be x, but transform vector O, comma, O transformed. Now m transform vector v, comma, v transformed. Now local screen grid size, I might make all these locals into globals inside here, you know that. Screen grid size equals vector transformed x minus origin transformed x. Now I am going to make this because this is cleverer. So it's screen grid width equals that, and screen grid height float equals the vector transformed y minus the origin transformed y. Now it's now I'm saying the origin transformed minus. I'm not thinking this through at all. It's, you know, this is the way it goes. I had an idea, and now I go through and obviously find out it's just much more difficult than I thought it was. Look at this, face left. Where do I put this? It's like, this is the constraints of the screen, and it is important. It's important. And it's a rectangle. Do I want to I'm going to end up sending a rectangle as well. Do I have a rectangle? I don't think I do. I do have a rectangle elsewhere, it's just never, believe it or not. I do. I'll shut my mouth. Okay, so I have a rectangle and it's really simple. I'm going to have to send a rectangle as well. This is not even a good kind of rectangle. I've got a better one inside GUI. This is I know it's bad, a bad show. But I've got sides, left, right, top, bottom, width, height, all private. I could send a set of GUI sides. Sorry to be just going around in circles here, but I am trying to think about the most sensible thing to do. I should, because I could keep a set of sides. Okay, yeah, I will. This seems upsetting in a way, but let's just get up and have a look at all these variables. There's some global stuff, and there's my fields. Origin transformed, out vertices transformed, path vertex transformed. Just looking through these and seeing that there's not that much stuff here. Covered control, what's that? That is pretty weird. Oh, it's covered control unsigned int. Oh, right, yeah, no, it's to be set to one of these, sorry. Being vague, okay. Now, if I set a field which is constraints, did I call it constraint or constraints? List snap equals new list snap. There's the list of constraints. And I have another field which is transformed sides. Yeah. Transformed sides. I hate that. Really. I've made a mistake. I hate it because it's a great big long name, but it makes sense. Transformed sides, and I'm going to have another method which is to transform the sides, because my mouse wheel is going to drive me insane. I have to just get a better mouse, because the transformation of the sides is actually here. Hang on. Wait a moment again. When do I ever actually use the transformed sides? That is L. The transformed sides are like the sides in the world. I don't actually use those inside this, do I? I just use this on-screen sides. Yeah, face top, face bottom. Those are the on-screen sides. The transformed sides, I have a feeling the reason I had this remmed out all the way back at the beginning was that I just had discovered I never used the sides of the thing in the world. But my brain is hurting because I think actually I will want that at some point. I'm going to leave it there. But I need to pass the sides in. I know the position of the sides on the screen. See, this is like I can pass in the face. If what I'm worried about are sides, then I can say that one of the things that gets passed in is sides. Sides. And I won't call it sides, I'll call it S, because I want it to be small, because not very good that way. Call it S, sides equals null. If not M or not G or not S, I'll return. Okay, sides. So here in finish draw, that's just gone beyond a joke. I also need to pass face, because the face describes the face of the gadget on the display. Left, right, top and bottom with a width and height to figure out. The face of the gadget can occupy the entire size of the gadget. If the gadget has borders around the side, then the face of the gadget will be within those borders. But it determines the constraints of the outside of the gadget. So I can pass in a side, so sides. So now I know that, sorry, let me just make sure this, yeah, okay. Setting that vector, then transforming it into the world space so that I know that I have the right screen grid width and height. Why did I call it? I called it temp number, didn't I? This is actually like a column number. Column. Call num. this call pause really? This is what gives me call. No, it doesn't. This is getting the offset. What was that called before? TN, num lines, face width. This now is S width divided by SGS. And this is not FL, this is sides left and sides right and sides width and num lines. This is sides top. This is sides bottom. And this is color AV, C AV, line mode alpha, off plus SGS. Okay, now also this is screen grid width, screen grid width, OTX, origin transformed, should be, because of my nice consistent stuff, origin transformed, off equals call num minus int call num. I'm going to call this something different. What really is it? It's like it's like a low. I hate to say this. I hate to think this way. It's like start. I'm just going to call it start. Sorry, I'm being vague again. Start minus the integer of start multiplied by screen grid width plus screen right. Boy oh boy, number of lines equals unsigned int equals screen minus divided by screen grid width. N equals 0 until num lines off top to bottom, one wide. Color, blend mode alpha, off plus screen grid width. Sorry, okay. This is gonna happen. I call this temporary number again. That's not, it's start. More or less where it starts, kinda. It's not really start. And start. And this is now origin transformed y minus S top divided by screen grid height. So start divided by times screen grid height plus S top. Yeah, these are the transformed. Number of lines equals u int face height divided by screen grid height, and it's not face height, it's S height. That is okay. Face left, it's now S left, off to S right, off 1 C AV. Right, okay. Off plus screen grid height. Okay. Okay, don't want that anymore. So, a matrix, color, and on-screen sides. Right. The matrix to take from world